Welcome back, everybody. So what we have this time is yet another tool repair. So I have this set right here. This is actually from the school. It is a snap-on tool, or to be more precise, a blue point tool, and they don't make it anymore. So most of you guys realize that if you buy a snap-on tool, blue point, they'll replace any of the broken components for life. But when it comes to a component that's not available anymore, then you have the option of an upgrade or the tool that they have at the time. So this is a bearing puller, specifically for pulling pilot shaft bearings out of the end of crankshafts. So the instructor that does a lot of the transmission classes was doing, or was working on a clutch job with his class, and they went to use the pilot shaft or pilot bearing puller, and somebody had their way with it. So if you take a look at this and I turn this, you can see it's bent. Well, this was bent like this earlier. This threads down right here. In order to get this apart, I had to straighten it with a hammer to straighten it out a little bit. And when I did that, I could feel the metal fatiguing, kind of like getting softer. Kind of like when you're tightening a bolt and just before it's ready to shear, you feel that soft, the oh God, it's going to snap moment. Well, that's where we are with this right now. I straightened it out enough to get this to come up far enough so that I could remove this, because it's threaded into this pot. But it's never going to perform the function that it's designed to like this. I don't know how this got bent. It really doesn't make much sense, but you're working with students. Students are learning. Sometimes they get a little overly aggressive with tools. The other thing is, if you look at the end of it, somebody's either put it in a vise or vice grips or something trying to separate this, and I will tell you this was very hard to separate. Here's another one in the box because it's two different sizes, and if you look at it, this is how bugged up the other one was. I just kind of filed it a little bit, and I grabbed it with a set of soft jaws to unscrew it, and it's in there pretty tight. So how this works is it has a couple of different parts to it. It's nothing more than an expanding arbor. So you have these two little parts right here that have a elastic around them, or an O-ring, and they fit between these two angles, and as you drive it together it expands. So if I had a bearing something like this in the end of a crankshaft, or in a blind hole, something like that, I could put this in here and I could adjust this until what's going to happen is, once it finds that inside diameter, you snug it down. You don't have to be too tight, just snug it down. There is a lip on this component that it expands wider than, or bigger than, the ID of that bearing. So now it's locked in there and it's grabbing the backside of that bearing, the inner race. You take this component, slide it on, and then the nut, and you screw this down, and what it does is it draws that out. Now there is another cup for this specific one. This bearing is a little bit larger than what you would normally see in a pilot bearing, but you get the idea. So it would pull it right into that cup. Okay, so they bent it, they fatigued it, we can't get another one. So we searched around trying to get just that component, So these are the pieces for this particular one, this size. I unscrewed it from here, and I'm going to tell you, it was in there tight. And what I found was there was a little metal piece in there, and I'm not sure what that's for. I don't know if that's to allow this to go down further and shorten it. I don't know, but that's what was in there. When I pull the other one apart and make one for the other one, we'll see what happens. But it just threads down in there, and that's all there is to it. So this is bent, and we got to make a new one because we can't buy a new one. And it's too soft to use. I think at this point in time, if I bend it some more to get it straight, which I probably could, it's going to fatigue enough to crack. Because I mean, it was bent over like a 30-degree angle. It was pretty bad. So what we're going to do is we are going to make this screw, and it's a pretty easy project. Okay. So it's going to be about 2 1/4 inches long. It's got a 30-degree angle to this plane, 60-degree included. This is a 1/4 28 thread, simple. I'm going to use a die to thread this. I don't like single point and small components unless I absolutely have to. To me, there is no reason. This is a production pot. And then we're going to put a little recess in here for those little fingers to sit in. So I took all the dimensions. I don't think anything on here is super critical. It's going to be pretty easy. In fact, I'm going to make this angle right here with the tool. So I'm going to use, I don't know, maybe a WNMG insert. When I come in, plunge in here, I'm going to cut this, and I'm going to make that angle all in one shot. Okay, I'll step it, then I'll come over and I'll clean it up. It's made out of soft steel right now. It is not hot at all. I'm going to make it, I found a piece of W1. So it's water quenching tool steel. So I think what I'm going to do is I'm going to make it out of that. I got a piece of 1/2 inch. This outside diameter right here is 445 thousandths. And it's small enough where it'll drop into a roughly a 1/2 inch ball with no problem. So I'm going to make it out of the W1. We'll turn it up, thread it, and then we'll heat treat it and dunk it in some water. Okay, pretty simple. It should be stronger than the component that's here. It's going to work better than the one that's here because they tried to use this and it just wouldn't center up right, for obvious reasons. So we're going to try to get it back to them so that they can do this job nice and easy, and the car will be on its way. Okay, so next time I see you, we'll be over at the lathe, and we're going to set this up. And I'm going to do the same thing I did when I was turning the screws for my little toolmaker's clamp. I'm going to put a center in here because I'm going to hold it. And I'm going to turn this first down below the root of this. And I'm going to hold it with my center here. And I'm going to turn that first, only so I don't have to keep plunging that when I'm cutting this. Then once I'm done, I'll put this is 1/4 28, I'll put this in a chuck, or in a collet, and then I'll face that off. Okay, just makes it easier to work with than to try to keep plunging in and leaving this piece out here where the center is. And I want support because you guys know that when you turn something, especially this long, 2 1/4, and it's going to be sticking out a little bit more than that, it's going to try and flex on you when you get down smaller. I mean, it's 1/2 inch now, and it's going to try and flex. When you get down to around the 1/4 inch, it's going to flex like crazy. So I want to keep a center in there, and we'll just face that center hole away later. So I got it set up in the chuck right now. It's sticking out a little more than 2 1/4. I'll come in here, I'll face it off. I'll put a center drill hole in there and put the center in it. I'll put the center drill hole in it, and then I will turn it down and put the center in there and hold it and finish up the rest of this. Okay, so I'll just be gentle. This is no precise size, just I like it under the root diameter of a 1/4-28. Even if it wasn't there, if it cut it with a tap, it really doesn't matter. I just want it smaller so I don't have to, smaller than the OD, so I don't have to keep plunging. Okay, so next time I see you, will be over at the lathe. Alright, that'll give me clearance so that when I start cutting this down, I should have plenty of room. Okay, so I can't really get it's going to take too sharp of an angle with the W and MG, so I'm going to use a CNMG cutter. And right now I got it set, so this is about 30 degrees, pretty damn close. And I'm just going to use that to make my angle. This should go back 2 inches. And like I said, this is nothing critical. It's just an adjustment screw. So I'm going to stay just short of 2 inches, and I'll finish up that once I get most of it all machined away. I'll come up and I'll touch it and make it what I want. So I'm going to come just short. maybe a 32nd or so. Right about there. Give myself a line. All right, let's give ourselves a line. So as you can see, I made a little bit of a bozo move. Nothing big. So when I put my line right here, I took the edge up to it rather than the point. Because when you start cutting it, it disappears. So I should have done it a little bit differently. So what I'm going to do, before I get down to my finished cut, I'm just going to put a little, I'm going to have to put some layout dye on here. I'll put a mark and I'll come up to that with the edge of this. Okay. Can't believe I did that. It was stupid. Alright, so we're going to come up to here. And again, we're going to leave it just a little short. Like a little mark here. This O1 and W1 does not like fine cuts. So I just took the hair off it. Alright, I'm 270 right now, which is 20 thousandths. 256. So like I said, I'm going to bring that about 5 under. It gives me another 10 thousandths pass, so it's going to give me a nice clean pass. And if it's not quite 5, I don't care. I just want to be a little bit under a quarter an inch. So 256. See what we got. What? 248. So we're not even. We're 1.5 thousandths under. I'm okay with that. All right, so we have to come in here and we have to put this undercut in. And again, this undercut, I mean, it's not critical because it's all relief. It's just so that the unit will close up enough to get through a hole. So we are plenty long enough.